this is a problem where when we had it on a test, you had to find all this stuff and you had to sketch it. On an exam like this, you'll just probably have to find some of the stuff maybe, but you don't know what, so we have to know how to find it all. And I don't think, we'll talk about this, I don't think we're gonna have you do any sketching. So I think we're just gonna have to find this information. Now, if the sketch helps you figure it out, that's great. So we have amplitude, period, phase shift, and vertical shift listed here. Okay, so what do you remember about anything about this? Anything at all, what do you remember?
-4. Oh, it's vertical at the end, +1.
Yes, so the vertical shift is up 1 or +1, right? Up 1, +1. That means if you were graphing the whole thing, you got it all graphed, you're just gonna lift it up 1 unit. All right, what else?
-4 stretches, like phase shift.
This guy?
Yeah.
No. This is actually your amplitude, that's your vertical stretch. So if I were graphing this, now I know it's been moved around and stuff, but just generally, the shape would be a negative sine curve and it would go down 4 and up 4. Now, because of the +1, those are gonna be adjusted, but initially, that is the amplitude. Note that it's positive, right? It's positive, all right? What about phase shift and period? Phase shift is horizontal shift. Horizontal shift is right, no, yes, right, pi/3, positive pi/3. So that means instead of starting at 0, the curve would be starting at pi/3. It would have that same shape, but it would be starting at pi/3. All right, and what about my period? Period is this length. How far is a sine, or what is the period of a normal sine? Just like a regular run-of-the-mill sine. 2 pi. Period's 2 pi, once around the circle, 2 pi. This number right here divides the period, so the period of this one is pi. Whatever that number is, it might be a fraction, it might be a decimal, whatever it is, that is 2 pi divided by that is your period. All right, 16. 32 students in a math class, 17 love both logs and polynomials, 20 love logarithm, how many love neither? What are you thinking about this one in terms of a strategy? Venn diagram, absolutely. You've got these groups of people that are overlapping each other. There's 32 of them. 17 love both logarithms and polynomials, right? So 20 love log, okay, don't put 20 here. 20 is the whole circle, so there's 3 here and 5 here because 22 love polynomials altogether. How many is that inside that circle right there? Or those circles? 25. Wait, there's supposed to be 32 in there, so what does that mean? 7 don't like anything. Number 17. What is the probability of randomly guessing 4 questions, exactly, 4 questions correct, on a 10-question multiple choice test, where each question has 5 options? All right, what are you thinking about that one? It's pretty recent material.
Robbie's that song we were in.
Yep, I hear him over there mumbling something.
He's sounding a little crazy.
So you sit down to take the test. It has 10 questions on it, and you're gonna get 4 of them right. Do we care which 4? So we're gonna start with 10C4. So the first thing you're doing is picking the 4 you're gonna get right. And the order doesn't matter, we don't care, just we want 4 of them right. What's the probability of getting a question right?
1/5.
1/5. And I want 4 of those. What's the probability of missing it?
4/5.
4/5, and I guess I want 6 of those. And that will be the answer to your question. Find the fourth term of x plus 4y to the 8th. Now, you got a choice here. You can either write out Pascal's triangle all the way to the 8th row, which isn't that bad. It takes a lot of space, but it's not that bad. Or, what else could we do? What? The combination numbers. So if you are interested in this row of numbers, you can either build it and get them that way, or you can remember that this guy right here is 8C8, 8C7, 8C6, 8C5, and so on down the line, all the way to 8C0. Well, I already have them written out, so I'm just going to use those. And I want the fourth term, so the number I want is 56. 8765. If you typed 8C5 in on your calculator, it'll say 56. And notice I just counted nothing special there. All right. Now, next to that 56 has to be an x and a 4y, because those are the two parts of the problem, right? And then, I think I turned this on. Did I? I came over here, but who knows if I did or
I don't know
not.
if you
No,
can
I
manage. The
didn't.
ringing is just drowning everything out.
Stop it. All right, so, everything's good here except the exponents. So what are the exponents going to be? Well, again, I'm going to count. Here, the exponent on the x would be 8, because it's to the 8th power. And then 7, 6, 5. So that's a 5. And if that's a 5, then that's a 3, because I am expanding x plus 4y to the 8th power. Right? Now all I gotta do is simplify. So I've got a 56, I got an x to the 5th, and I've got a 64 y cubed. So 56 times, it's all multiplied. So 56 times 64, the answer is 3,584 x to the 5th y cubed. Number 19, how many ways can a teacher give away a marker, a book, a crayon, and a calculator to different students in a class of 24? So basically, here I am, I have these 4 prizes, I'm gonna hand them out. There's 24 of you to pick from, not today, but usually, and I'm going to hand out these 4 prizes. So is it 24 P4 or 24 C4? P. Why is it P? Because the prizes are different. You care if I give you the calculator or not, right? Who wants a marker if you can get a calculator? I know. Okay, so the answer to that one would be 24 P4. 24 kids, picking 4, order matters. Done. Type it in on your calculator, whatever it says, that's the answer. Now 20. How many ways can I choose 3 boys and 3 girls from a group of 6 boys and 7 girls? So this is like a card problem. Only instead of picking diamonds and clubs, I'm picking boys and girls. So how do we do this? How many boys are there? How how many am I picking? And the order doesn't matter because I'm picking a committee. So I'm gonna start with 6C3. And 7C3. That's it, that's the answer. And whatever that is, when you type it in, that's the answer to the question. Now 21 is a card problem. A 5-card hand is dealt from a standard deck. What is the probability? Now, this question is going to be a fraction. Probability. So what goes in the bottom? 52C5. Your denominator is never going to change if it's a 5-card hand. If it's a 6-card hand, it's 52C6. Now the numerator is what I want. Now what do I want? At least 3 aces. So what does that mean? I could get 3, or I could get 4. Okay, so what does 3 look like? Let's start with 3. Now you're going to get 3 aces in this hand. 4C3. There's 4 of them, kids, and you're going to get 3 of them. But don't forget, it's a 5-card hand. So you're going to get 3 aces and 2 other cards. And where are the other cards coming from? The other 48. Now, some of you, like, I don't know, you come up with all craziness here with this number. I'm not sure, what's going through your head. Here's what I want you to think about. If you want aces or not aces, split your deck. So there's 4 aces and there's 48 others. And somebody said, well, you only picked 3. No, I don't want any aces in this other group. So there has to be just 48 in this other group. Or I could have all 4 aces. So 4C4 and 1 other card. If you set it up that way, I like to set these up with just 1 denominator. You could do them as 2 individual fractions. But if you set it up this way, make sure you're hitting equals after you type in your numerator. Hit equals, and then do the divided by. All right, 22. Read that one and tell me what your thought is there. Do you have a thought? Tree? And I'm going to be in uniform, so uniform, not uniform. Alright. Late, not late. Alright, here we go. If a student is late, the probability he's in uniform is 0.38. So the other one's 0.62. If a student is not late, his probability of the universe 0.68, 0.32. 24% of the students are late. Find the probability the randomly selected student will be in uniform. We can do this, right? Uniforms here and here. So I'm going to multiply 0.24 times 0.38, 0.76 times 0.68, and then add those together because it could be this way or this way. All right, 24. Eli caught 2 baseballs on the first day, 5 on the second day, 8, 11, and so on. How many will he caught altogether if he continues this pattern for 100 days. Well, these formulas were on the screen. I didn't pull them back up because it's hard for me to do because I'm technically challenged. But this is going to be a series problem, right? Sequence and series. What kind of set of numbers is this? Arithmetic. You have two arithmetic formulas. Here they are. These are your two, there's only two that are arithmetic. There they are. This question says, how many will he have caught altogether? Some. And I'm doing it for 100 days. So I'm adding up 100 days worth of stuff. So the formula says 100 days is 100 over 2. First term is 2. Uh-oh. What's that? That's the 100th day. And I don't know what that is. So what do? Use the other one. So the 100th day is the first day plus the common difference times 99. I think that's 299 if my math is right. That is not the answer though. That's what you're going to plug in right here. So 2 plus 299 times 50. Looks like 15,050 is how many balls he will have caught altogether. Okay? 26. Write 0.27. I'm gonna write it out. As a fraction in lowest terms. Now note that the bar is only over the 7. So when I go to split this up, the 0.2 is a separate thing. So then the first repeating part is 0.07. Because if you add 0.2 and 0.07, don't you get 0.27? And then 0.007, and so on. All of this is geometric. Right? What's the ratio? 1/10. The ratio is 1/10. I'm dividing by 10 each time, so multiplying by 1/10. This part is summable using my infinite geometric sum formula. Remember, it's just the sevens part. That's extra. So 0.07 over 1 minus 0.1. The ratio is 1/10. 0.1. That's what you're multiplying by. So I got 0.07 over 0.9, which is 7 over 90, if I move the decimal point 2 places to get rid of it. Now what do I need to do with that 7 over 90? Yeah, all this is 7 over 90. So I need to add it to 2 tenths. Add that part back in. So I get a common denominator. So it looks like, is that 25 over 90? Which would reduce 5/18. I can check that. Oh shoot, it's not on the calculator part, so I can't check it. But I'm gonna go ahead and check it anyway. 5 divided by 18, sure enough, 0.2777. All right, quickly our limits. What's the limit for problem A, 27A? Guys, the limit is 3/5. Yes. No work. It's there. 3/5. Same as the horizontal asymptote. What about for B? B is not that kind of problem. B is a different kind of problem. 0. Why is the limit 0? Because 4/5 is less than 1. It isn't because it's a fraction. It's because it's a fraction less than 1. Perfect. Okay. And then one more. number 28. Yeah, last one, number 28. Now, when we did these, both in chapter 2 and in chapter 7, so we've done these twice, we had these big things. I'm gonna go ahead and factor, because I'm running low on time. I'm gonna go ahead and factor. And you had to find everything and sketch it. That is not happening on the exam. You're gonna have to be able to find something. What are you gonna have to find? I don't know. Could be vertical, horizontal asymptotes, x-intercept, y-intercept, or holes. Now, I factored my problem. That's always step one. Tell me about holes in this problem. There aren't any. How do you get holes? How do you know when there is a hole? You cancel. Now, let's suppose these canceled out. They didn't, but let's suppose they did. And it's because I had both of these. Then my hole would be where x is 3, because I'm canceling out 2 of these. I'm pretending this is up here too. And then I would take that 3 and plug it in here. So I would get 4 over 6. Okay, that would be where my hole is if I had one, but I don't have one. All right, how about vertical asymptotes? They come from the denominator. So my vertical asymptotes are -3 and 3. Now, if something cancels, then that's gone from the problem. And you only have one vertical asymptote then. We have 2 because nothing canceled. Horizontal asymptote, look at the problem. That's the limit, guys. It's 1, y equals 1. X squared over x squared. X-intercepts come from the numerator. What makes the fraction 0? What are the zeros? Well, the zeros are -1 and 1. And then how do we get a y-intercept? We let x be 0. I like to do that in the original problem. I think it's easier. So that would be 0, 1/9. So on the test, you're going to have a problem like that. I 100% guarantee it. And you're going to have to find something. Not everything, but you know what you're finding, so you better find it all. Okay?